We're going to be solving linear equations by graphing. Okay, and just for our warm-up, let's quick review how to graph an equation by making a table. And the way to do that is to make our little XY chart and then plug in the values. Remember, you need 3 values to do that. So go ahead and do this on your own. Pause the video, then check your answer when you're done. So now that you're done, the 3 points I usually plug in, as long as I don't have fractions, are 0, 1, and 2. So when I plug in 0 for x, y is 4. When I plug in 1, y is 6. When I plug in 2, y is 8. And then I just plot those 3 points. 0, 4, 1, 6, 2, 8, and then make my line. And hopefully you can draw a line better than me, but that is basically what our line should look like. So now, talking about solving by graphing, we've already talked about what a linear function when you have a line. And the simplest linear function is just f of x equals x, or sometimes we think of that as being y equals x. And we call that the parent function. And basically what you think of with a parent function is this is what the graph always starts out looking like. And then we're going to have this family of graphs where things change it, and it's going to maybe look a little steeper, or maybe it will start out a little higher. But notice, these 2 lines still look kind of like this basic linear function. And the way to remember this is like a parent function is if you think about your parents, okay, they look a certain way, and then they might have a family, so a bunch of kids, that all look similar, so you can tell they kind of look alike, but the kids don't look exactly the same. Sometimes kids are taller, okay, sometimes they have different color of hair, but they still look similar to their parents. And then the last thing I want to talk about on this slide is that the solution, or root, so I want you to box in root of an equation, is a value that makes the equation true. Okay, a root is basically an answer. That's what we've been finding before when we were solving these equations. We were technically finding the root. The root is just the answer. And a linear equation has at most 1 root. So you can have 0 or 1, you can't have more than 1. And you find the root of the equation by graphing its related function and basically replace f of x with 0. Basically, we're trying to find where the function is 0. That's what a root is. We are finding where the function is equal to 0. That's a root. And then if we think about these zeros, and again, when I say zeros, it means the same thing as roots. Okay, it's the exact same thing we just talked about. Zeros are just roots. It's where the equation would equal 0. So let's look at our first example. We want to solve each equation. And when I solve these, I'm trying to see where is this 0. And you guys have done this enough that you know how to solve this by just solving an equation, solving for x. Let's solve this though using a graph. Let's see where 1/3 x minus 2 is equal to 0. So I'm going to say y. I'm going to replace my 0 with a y. And I'm going to say, where is this graph, 1/3 x minus 2? I want to know where it equals 0. And then I just have to graph it. And I go 0, 1, and 2 for x. And then I plug in find out what I get when I have 0. I have -2. When I have 1, I have -5/3. Because if I plug in 1 for x, I get 1/3 minus 2, which is -5/3. And for 2, I'd get -4/3. Then I just plot these points, 0, -2, 1, -5/3, 2, -4/3. Then I'd graph this. And I can see right about here-ish is where the graph crosses the x-axis. That's where my 0 is. My 0 is where it crosses the x-axis, and if I count over 1, 2, 3, 4, 5, almost 6, which hopefully you guys know this should be 6, you can say x equals 6. Now, this is not the best way to solve these problems, okay? Because when we're graphing them by hand, it's really hard to see where exactly it crosses the x-axis. However, we can use technology to help us, And in class, we will actually be using a graphing calculator to find where it crosses the x-axis. But for now, just do your best, plot the points, and estimate where it crosses the x-axis. Second one, now there's two different ways to do this. What I'm going to say is we're going to have always this right side equal to 0, so I've got to solve it for 0, so I'm just going to add 2 to each side. So now I've got 3x plus 3 equals 0. Now I'll be able to find my 0. So I'm just going to rewrite this equation. 3x plus 3 equals y. I replace the 0 with a y. And then I make my table. For my three different values, 0, 1, and 2. And when I plug in 0 for x, I get 3 for y. When I plug in 1, I get 6. When I plug in 2, I get 9. So now I just got to plot my points. 0, 3, 1, 6, 2, 9. And then I plot my line. And I can see it's about x equals -1. And again, I'm not so concerned that your graph looks perfect or that you can tell exactly where it crosses the x-axis. I want you to understand the process of what we're doing, and I want you to understand that this is the point we're always looking for. We are looking for where the graph crosses the x-axis, and we call that the root, or we also call that a 0. You're finding the 0 or the root, and you do that by graphing and looking where the graph crosses the x-axis.